This is ELEC 1510 Logic Design Lecture 7, Video 1 on 4 variable Carnot maps, corresponding to textbook section 3.3. 4 variable K-maps or Carnot maps are a simple extension of the idea of Carnot maps in 3 variables, so this is going to be a pretty short video. What this looks like is instead of a 3 variable K-map with 8 minterms, we have a 4 variable K-map with 16 minterms. So let's fill in what the minterms are going to look like in this K-map. Let's just say that our K-map is in terms of variables x, y, w, and z. So when on the horizontal axis we have 0, 0, that corresponds to x prime, y prime. 0, 1 is x prime, y. 1, 1 is xy, and 1, 0 is xy prime. Now remember, you have to jump from 0, 1 to 1, 1 because only one of those bits can change at a time, and then we jump over to 1, 0. That works the same on the vertical axis, where we go from 0, 0 to 0, 1 to 1, 1 to 1, 0, because we can only have one bit change at a time for adjacent terms that can be combined. So 0, 0 corresponds to w prime z prime, 0, 1 is w prime z, 1, 1 is wz, and 1, 0 is wz prime. So we have minterm 0 in the top left corner, that's 0, 0, 0, 0, and then minterm 1, then all the way in the bottom left is minterm 2, and one box up from that is minterm 3. Then if we move one row over, we've got 4, 5, 6, and 7. And now we have to jump all the way over to the right side to get to 1, 0. So minterm 8 is up here, 9, 10, and 11. And then the third row over from right is minterm 12, 13, 14, and finally 15 is 1, 1, 1, 1. Okay, so now we can do some examples of simplifying functions using a 4 variable K-map. So let's work on simplifying wx. Function 1 of wx, y, and z is the sum of minterms 2, 3, 5, 7, 10, 11, 13, 14, and 15. Okay, the variables here are in a slightly different order than how I wrote them on the last slide, so I'm going to write w, x, y, and z. Again, it doesn't matter what order you put the variables in, the function will be simplified the same either way, just the bubbles are going to look different depending on what order you write the variables in. Okay, so now we have to put 1s for any minterm that's represented in the function. So 0 and 1 are both zeros. Minterm 2 and 3 are both represented, so those become 1s. Then minterm 4 is not represented, 5 is, 6 is not, 7 is, minterm 8 is not, 9 is not, 10 and 11 are, 12 is not, 13 is, and 14 and 15 are. So now we can see that there's some nice structure to the placement of these 1s in the K-map. So now we can start actually circling bubbles. One easy bubble to circle is this row of 1s. That can't be expanded either up or down. So that's about as big as that bubble can get. Again, to expand a bubble, you have to double its size. We can't double its size to the left or to the right because K-maps wrap around, so there's no room to expand there. Up or down, we would be including zeros, so we can't double its size. So this is one of our main terms in the simplified function, which is going to be yz, because along the length of the bubble from left to right, both w and x will be both 0 and 1. So we have w being a 0 here and being a 1 here. We have x being a 0 here and a 1 here. So w and x are not represented in that term, but along the length of the bubble up and down, y and z are only 1 and 1, so that term is just yz. All right, now another bubble will be right here. I see 4 1s that are all adjacent. Now, along the length of that bubble horizontally, w is 0 and 1, so w is not represented. X is 1 and 1, so this bubble has an x. Along the vertical side, y is both 0 and 1, so y is not represented. Z is 1 and 1, so we add a z, and that bubble represents xz. All right, we still have a couple more. There's a bubble right here. That one can't be expanded to the top or bottom or left or right to double its size because we would be including a 0 either way. So this is as big as that bubble can get. And that one is going to be wy. All right, we still have one last little one there that's not covered by a bubble yet. That's this one. And so the largest possible bubble that's going to cover that one is a bubble that wraps around here. And that bubble is going to be x prime y. So in total, when we simplify this function, it comes out to the sum of all of these terms, xz or yz or wy or x prime y. Let's work on simplifying a function given a somewhat moderately simplified Boolean expression. This is not a sum of minterms, and the terms in this function aren't minterms, as you can see, but it's not completely optimized. This function is in terms of a, b, c, and d, so let's write those in the K-map. Again, you can write them in any order you want, and you will still get the same optimized expression, just the bubbles will look different. So our first term here, a prime, b prime, d, we need to look for a bubble where a prime and b prime are both 0, so that would be here. And d is always 1, but c changes, so it's not represented. And that's going to be right here. So we can put 1s right there to represent this term. Now let's move to the second term. I'm going to use a different color for this one. A prime, b, c prime. So we have to look for where a is 0, b is 1. That's going to be right here. And where c is always a 0. So that's going to be here. D is not represented. Now a, b, c prime is our next term. That's where a and b are both 1, so that's here, and c is a 0, so that would be right here. Our next term is a, b prime, c, so we need to look for where a is 1, b is 0, that's here. I'm just moving along the columns essentially right now, and where c is a 1, so that's going to be here. And the very last term in this expression is a, b, c. That's where a and b are both 1, that's here, and c is a 1, so that is right here. Okay, now I will just fill in zeros for the rest of the min terms. And now we can start to optimize this expression. So there are a few different ways to go about doing this. It looks to me like this bubble is going to be one of the essential bubbles. And that bubble is the term BC prime. This bubble is one of the essential bubbles. This one is going to be AC. And then finally we have this term, which didn't get simplified into another bubble, which is A prime, B prime, D, the same as the very first term in the original function. Now what you might see is that it looks like there's a row of 4 right here, which is what makes this a little tricky, but that's covered both by the other bubbles already, so you don't really need that one. If you included that, then it would be redundant, because basically the remaining 2 right here would also be covered by this bubble, and then you wouldn't need the tall bubble. So sometimes it looks like there's a row of 4 that's necessary, but you don't actually need it because it's redundant. So then finally, our optimized expression is BC prime plus AC plus A prime B prime D.